Alright, here we are on packet tracer number 8. This is packet tracer activity 6335 in the CCNA Discovery Learning Guide by Cisco. I'm Brian Torres, and in this activity we're going to be viewing PDU information between a client and a server. So kind of similar to what we did last time, except for this time it's a PDU instead of just regular packets. Excuse me. The first thing we're going to do is we're going to actually just enter into simulation mode. We're going to create the complex PDU. Let's edit our filters here first. We have HTTP, TCP, which is what we should have. We create our complex PDU. We're going to click the external client PC. So that's our source. We're going to set the application type to HTTP, and we're going to click the Cisco Learn web server here as our destination. That fills in our destination IP address. Our source port is going to be source port 1000. We've been through this a couple of times now. Our interval periodic 120, and we should be good to go from there. Create our PDU, double click our panel. Not sure why it really wants us to do that, just so that we can see what's going on. We can move it out of the way. We're going to click the auto capture play button here, but I always like to speed this up because it goes so slow if we don't. So here we go, and now we're cruising with PDU sent across the network. So here in a second we'll be done. Once again, because this is TCP, because it's HTTP, which is a TCP protocol, the client the client's always looking for a confirmation that the packets have been sent. So it takes a lot longer to process. So here we can click any one of these according to our there we go. And here we can view the OSI model of the packet that was sent. So here we can see that layer 1, the port, the fast Ethernet port, sends out the frame. Layer 2, it gets an Ethernet 2 header. And this just explains step by step what's happening. And then here you can see that how everything was sent. And depending on where the packet is, we might be higher or lower on the OSI model here. We're lower there. We didn't have any software to strip the packet down. It's already stripped down. look at when it gets all the way out here. We're back up to port 4 or layer 4, which is the source port, the destination port. And we can go down all the way to see what happens in here. We have a remote switch there, and in here it should be down only 3 layers. So basically what happens is layer 1, the port serial, received the frame. The device de-encapsulates the payload from the HDLC frame and sends it to the upper layer. And here the router looks at the destination IP address in the routing table. So that's the same thing. It gets sent on to the out layers, which is the routing table finds the routing entry to the destination IP address. The destination network is directly connected, so the router sets the destination as the next hop, and then the router decrements the TTL on the packet, so it basically sends it back down. Next hop is the IP address as a unicast. The ARP process looks it up in the ARP table. The next hop IP address is in the ARP table, so the ARP process sets the frame's destination MAC address to the one found in the table. And then this layer, it sends it out. So that just keeps happening over and over for every device as it goes through. And it all happens fairly fast. I mean, it only took 257 seconds for it to travel all the way across. And that should be about it. Check our results. There we go. We are good. Yay!